What's up, everyone? Today we're going to be working on a project that I've been needing to do for a while. I have a really bad habit of when I solder, I just sort of go to an open space, hold my breath, solder, and then blow all the air out and kind of run away a little bit in order to try to avoid breathing in some of those fumes. So today we're going to be building a fix to that problem. And I'm not the first person to have ever done this. There's a lot of videos out there, but this is going to be my version. So stick around and we'll have some fun. Alrighty, so I went ahead and I gathered up all the materials that I plan to use for this project. Probably the two most important pieces are this carbon filter to actually filter out the fumes, and this pretty cheap, it's like 5 to 12 volt fan. And I'm going to be modifying this a little bit so that it works better for what I want to do with it. And then we've got a couple of batteries that we're going to use. I am going to actually add a solar panel to this, which hopefully that works out. And then we've got a little charge module, so I should be able to charge up my batteries via a USB plug-in or through my solar panel, and then just a little switch to turn it on and off. So I do want to talk a little bit about using batteries in projects and how to plan that so that you know you're safe and going to have the power you need for your project. So let's jump into that next. So the first and most important piece is we need to know how much power this fan is actually going to draw so that we can calculate everything else. Now, we know that it can draw 5 volts, 9 volts, or 12 volts with changing this little switch up, but I don't know how many amps it's going to draw at each of those voltages. So I've got this little guy. Once I plug it in, I can plug my fan into it and then get a reading of how much it's actually pulling. It looks like we're getting about 0.13 amps with the 5 volts, but now it's increased its amps up to 0.18, and this is at full speed, and we're at 0.24 amps. Okay, so here we have our calculations. And what I wanted to know is watts. So I'm trying to calculate from my volts and amps that we saw into the watt amount, okay? And so I did that for the first setting, the second setting, and the third setting, which I believe are going to be 5 volts, 9 volts, and 12 volts for the fan, okay? And so I calculated that. I now have the watts that the fan is total consuming when I have it at each of those levels. So the level I want to use is that second level, which I believe is at 9 volts. And so I've taken the amount of watts that the fan consumes at that stage. I divided it by the number of volts that I have planned to supply to the fan, and that will now give me the number of amps that it will be consuming, and I'm going to use this number to understand how long can I run my fan depending on the batteries that I'm using. So we're going to do that calculation next. Okay, so I went and looked up what capacity my batteries have, and it's looking like they're going to be 1,500 milliamp hours. So if I want to convert that and understand how many hours I will be able to use this fan for, I first need to remove the milli of the milliamp, right? So we got to move our decimal place over 3. So that puts us at 1.5 amp hours. So what that says is I can use this fan, or I can use this battery. It will supply 1.5 amps over the course of an hour. So we're going to divide my 1.5 amps by the amount that we think we are going to actually consume, and that should give us the amount of time that this battery will be able to supply appropriate power to my fan. Okay, and we're back after a quick calculator break, and yeah, I should be able to run this fan for 14 hours with only a 0.1 amp pull that is happening. So pretty solid amount of time, way more than I'll ever need. So my next step, now that I have all my calculations, I know that my batteries are gonna be able to run my fan for as long as I would like. My next step is to get everything measured and sort of planned out in Fusion 360. So we'll hop over there and see what this monstrosity is gonna look like. Okay, so usually when I go to design something along these lines where I have a lot of moving parts, what I like to do is first design the different parts. And then I will go and I will move those parts into about where I would like them to be placed. And then I build around them. So you'll be able to see what I eventually ended up with being built around all of these different parts. So I just wanted to go ahead and show or talk about some of the choices that I made on the design. So originally I had thought that I would bring this lip up and kind of have a little hook for placing the little pad that will go in front of the fan. But I figured that as long as I have a tight fit, I can slide it right in there. And honestly, just like a rubber band over the top will be more than enough. So a little bit barbaric, but it should work just fine. And then I threw in some screw holes where I could connect the fan. And then from this bottom side, little nook to be able to pass wires from the fan into where all the other pieces will be. And then solar panel is on the bottom, so that's covering up this entire space. So I have a little lip that sort of catches my solar panel, and that was actually designed with a little chamfer so that I could print the entire thing upside down and I wouldn't have to use any supports for that. Okay, so this is how it came out of the printer. Looks pretty good overall. Can't really complain. Printer did a pretty nice job. The next step that I think is important is just to test the fit of everything. This USB was a little bit tight, but it did fit in the end. And this switch went in beautifully. And then the solar panel was looking pretty good as well. The next thing I needed to sort out was this fan. Needed to make sure that my screw holes would be in the right place and get everything screwed in. So this was actually quite the process. What I had not planned for was how to push those screws into the screw holes, and it was not a fun process. So eventually, with a little bit of prying and pushing and twisting, we got that in. I wish I would have made those holes a little bit wider because that would have made this whole thing easier. Eventually, I did get it in there, but I wasn't super happy with the fit. The little metal bracket on the side of the fan caused it to slant, which I didn't love, and you can kind of see, I slowed it down so you could see that here. So after all of that super fun trying to get it into place, I decided I had to take it apart, and I actually flipped the metal bracket thing that covers the fan around and put it all back together. Wasn't exactly fun, but I figured this was going to be better than the alternative. It wasn't perfect afterwards, but it was definitely a lot better. Next, I just sort of started trying to put this cord into place, which was actually not according to my original plan. The astute observer among you might notice up in the right corner I only have 2 batteries there now, and that's because I realized that my charge module could not charge 9 volts. I don't know what I was thinking. Those charge modules are only for single lithium-ion batteries. So instead of wiring up my batteries directly to the fan with a switch, I'm going to be using a different boost converter module that will take my batteries from the 4.2 to 3.7 volts up to 5 volts and then running the fan off of that, which should be totally fine. It just was a little bit of a pivot in the overall plan. Now, for some reason, these types of pivots seem to happen to me all the time. I'm not sure if it's a me problem or if everybody deals with this, but at some point in your project, you're gonna think that you have everything planned out, and you don't. So it's just part of the process, and you hope that your pivots and those little changes that you have to make later on can be done without having to replan the entire project. Fortunately for me, I didn't have to. So this next part that I'm getting into is just soldering my batteries together. They did have little metal tabs already, what's it called, spot welded into place. And so I could just solder directly onto those tabs. So that's kind of what I'm figuring out here. And then I went and grabbed this guy, just little arms to help me. Very, very helpful when you're soldering to have an extra set of hands, and those are pretty dang great for this. So just using those to hold my batteries and get them all situated. The other thing I didn't mention is this soldering flux that I have here. This stuff is magic, and it makes the soldering experience about 1,000,000 times better. It basically cleans and prepares the surfaces so that they will accept the solder a little bit better. So if you are going to do some soldering, definitely pick some of that stuff up. So anyways, I'll speed up this process a little bit. I just got those batteries all soldered up together. On one side, the tabs, little metal tabs, were close enough together that I could solder them directly with a pretty solid joint. And on the other side, I did end up having to use some wires to bridge them together. I could have done something else, but it was simple enough, and I had those metal tabs. So that's what we're looking at here. Now I am going to start a little counter here for the number of times that I end up waving my hand around to protect my lungs, I guess, in the worst way possible. And it's really just highlighted for me how badly I needed to build this project in the first place. So we're going to start keeping count. And now is your opportunity to guess the number of times throughout this entire project that I end up doing this hand wavy thing. If you manage to guess it, then I don't know, maybe I'll try to come up with some sort of prize to give to the victors. Anyways, we've got the batteries all sorted out, and I am now double checking the polarity so that I know how I need to wire everything up. If you don't know, when I connect my red lead up to the positive side of the battery, I should get a positive reading on the multimeter, and that's going to tell me which side is the positive side, the side that the red lead is touching. And here is our first look at that power device that I have. I'm going to be connecting this up to the batteries, and then that's where I'm going to plug the USB plug for the fan into so that I can power this whole project. Fortunately for me, that's able to supply 5 volts at 600 milliamps, which is more than enough power for this project. So I guess you just have to watch me solder now. You can kind of see here how I do the connection to the module itself. Just have to thread that wire through those little holes and then get them soldered in place here. And we have another wave my hand counter. Very nice. I really need to get some like background music or something, because this is less fun to watch even for me, and I'm the one that made this stuff, without a little bit of music or something to listen to. Instead, you just have to listen to me ramble. But I want to be able to show the entire process of all the work that went into each solder and all the connections that need to be made, so you can see the whole process. But I think I am going to skip through this a little bit because it's just getting this one thing connected. So let's go ahead and skip forward in time with a little bit of YouTube magic. So all complete, just doing a little bit of a test. You can see that there's an LED light on, which is a good sign, and it is able to power my fan perfectly. So super important step. That's all working, and we can move on. So as I started reviewing all of the footage, I realized there is a lot of me just soldering things, which is not particularly exciting. So instead I decided to give you this wonderful compilation of me waving my hand around like a maniac for all of the times that I just wanted to get that fumes out of my face. And wow, I really went ham there. So anyways, it ended up being a lot, and you guys really missed a lot of soldering, but I ended up soldering about 4 wires to my little charger device, and here I am getting it situated. And finally we're on to something new, which is hot gluing, which is also not very exciting. So I think I'm gonna just go ahead and skip ahead for all of your sakes. And yes, we are back to soldering. I had to get the switch all soldered up, and I actually had to disconnect it from the little charger chip that I had there so that I could put power to the switch, then to the charger thingy, so that it would actually work with the switch. So that's what we did here. And just a little test here, making sure that everything's working when I actually turn that switch on and off. The fan turns on and off, which is great. That's what we wanted. So now I do some more hot gluing, which I'm sure you want to watch. I did want to highlight here just how much hot glue I ended up putting on this cord, because yeah, let's just say that that was a mistake, and you will find out the reason why later. Also, notice the position that the little switches there. Yeah, I hot glued that face down, so that was great. Now we're going to go into the solar panel, and I think we're going to skip through most of that too, although we definitely want to make sure that we get a good hand waving counter going so that we get the correct count of number of hand waves here. And plot twist, that was the last one. So anybody that guessed 30, put it down in the comments. If you guessed it right, I don't know. Maybe I'll 3D print you something and send it to you. Sure, I'll commit to that. If anybody truly guessed 30, you gotta say that you actually guessed that, and I'll 3D print something random and send it to you. So anyways, the whole thing's put together and looking pretty good. I just add a little bit of hot glue to put it in place, and I am feeling good. I'm thinking, all right, everything is buttoned up. Time to throw on this little carbon pad thingamawhatsit for the filtering, and then I'm gonna test it and see how well it does as far as getting those fumes filtered away. And after a short amount of time, I realized to myself, that's not enough. So I quickly try to pull everything back apart here. Fortunately, the solar panel came off pretty easily. I had started doing this testing while the glue was maybe still a little bit warm, but yeah, that upside down switch and copious amount of hot glue, yeah, that was not very fun to try to get figured out, but eventually I got there, managed to switch it to the higher setting, and then I retested. And testing round 2, once I turned up that fan, was just perfect. So I was pretty happy with how it turned out. Okay, so we have the finished product here. We've got our fan with the filter, everything hidden underneath this solar panel that can sit in my window. It's too dark right now to have that do anything, but if that doesn't do enough, then we've got our little charging port here, and kick it on just like that, and been able to feel enough of a pull with the airflow to get those soldering fumes away from my lungs. So pretty fun project for me. I've enjoyed it, and if you enjoyed the following along on the journey, then please subscribe, because I will continue to be making more videos like this. So thanks for watching.